One is star connection, another one is delta connection. The load is also star or delta. So in star or delta, we have to see that mainly those some points. I'm not going to derive again the equation. Uh, yeah. So in three-phase AC circuit, three-phase AC circuit. In in three-phase AC circuit, mainly we have the star and delta connection. Star connection and delta connection. So here we have the phase value as well as line value. Phase value and line value. So we have to see that either it is in star connection or either it is in delta connection. We have to see that the relation between the phase value and line value. So first point is phase value and line value. Yeah. First point is so in star connection as well as line connection. Just yeah. So particular. So first point is the voltage, line voltage. So very simple, line voltage. So in star connection, just remember only one point. In star connection, please all of you listen. Just remember this point. Yeah. So in star connection, current is same. Either it is phase current or line current. The value of current is same. So here, if the current is same, then voltage must be difference. If the current is same, then the voltage must be difference. That the difference is here. How much it is difference? That is root 3 times difference between the line value and phase value. Root 3 times difference is there. So here, please remember this point. So line voltage in star connection, current is same. So it means if the current is same, then voltage is difference. So here voltage is line voltage VL, right? Line voltage always greater than the phase value, phase voltage. Either it is current or voltage, right? Line value always greater than. The greater than the difference is here. What? How much it is difference? Just we discuss. It is root 3 times difference. So VL is equal to here root 3 into V phase. VL is equal to root 3 into V phase. Here, voltage has the difference in star connection. So in delta connection, voltage is same. So that is VL is equal to V phase. This is the first one. Then second one, that is phase voltage. Phase voltage. So from this equation, V phase is equal to, how to write down V phase is equal to, V phase is equal to VL by root 3. Right? V phase is equal to VL by root 3. Here VL is equal to V phase. So at the same time, V phase is also equal to VL. Right? Then next one is the current, line current. Line current. So in line current is equal to here, IL is equal to I phase. coming to here, IL is equal to here. If the current is same here, then here it has the difference. The difference is the root 3 times. Then root 3 into V phase. Then next one, phase current. Phase current. So what is the phase current here? I phase is equal to IL. Coming to here, I phase is equal to IL by, sorry, this is I, IL by root 3, right? These are the line current and phase currents. Then coming to power in AC, sorry, star connection as well as delta connection. That is power is equal to power P is equal to, that is root 3 into VL into IL into cos phi. We derived all this equation. Here also, either it is in star or delta, power is same. Power is same. That is, here also power is root 3 into root 3 into VL into IL into cos phi. What is cos phi here?
R by Z.
What does it mean, cos phi?
Power factor.
Cos phi is the power factor. It is the power factor of the circuit. Right. So these are the equations. So if the three phase, uh, so after derivation, the relation between the phase and line, right? These are the formulas we get that. Okay, now?
Sir, sir, in the question, how will we get to know that given voltage value is VL or V phase, sir?
Sorry, voltage.
Given value in the question is VL or V phase, how we will get to know, sir?
Uh, See, generally, if it is small value, means if it is small value, if the voltage 440 or something, 440 or something, then yeah, if the voltage is some 440 volts, 440 volts, then assume it is voltage, line value. Because of the three phase supply, generally, if it is the utilizer side, means consumer side, yeah, okay. So here, if we are the consumers, we utilized the value. If it is three phase, right, it is the value we are. If it is three phase value, it is 440 volts. If it is single phase value, phase voltage means any between any phase and neutral. Here, line value and phase value difference means, here if it is consumers, these are the consumer sides, some 220 or 230 volts, right? This is the phase value. It is single phase value. See, it is nothing but, just if you observe the line in the outside of the our houses and in the streets, we have the lines like this. One cable, right? Another cable, right? These are the three phases supply. Here it is R, it is Y and it is B. And another cable is there. This is N, neutral, right? So between face value is nothing but clear గా మీకు రాపిచ్చాను అప్పుడు between any face to the neutral. This is V face. Between any face to the neutral. This is V face, right? Line value means between any two faces, between R face and Y face, whatever the voltage, that is line value, right? So these are the ultimately the consumer side. Ultimately, whatever the generating, whatever the transmission, whatever the distribution, right? Ultimately, consumer utilized. If it is three phase, 440 volts only. If it is single phase, 220 volts only. From the supplier end, maybe it is 11 kV volts, right? Or maybe 33 kV, or maybe some high voltage. That is the supplier end. But consumer end, this is the value. You got my point?
Yes, sir.
Yes. Yeah.
Sir, how to find real power and reactive power, sir?
Real power and
Reactive power.
reactive power is nothing but reactive terms. Real power is the V into I into cos pi. Real power or active power, that is P is equal to V into I into cos pi. Reactive apparent power, apparent power. Real power units are watts or kilowatts. Apparent power, that is equal to V into I only. Here units are volt ampere or kilovolt ampere. Right? Another power is there. That is another power is reactive power. Reactive power, that is equal to reactive power in sometimes we denoted with Q. Apparent power we denoted with S. Right? Then that is V into I into sine pi. V into I sine pi. The units are here volt ampere reactive or kilovolt ampere reactive. Okay, Rama?
So complex power also.
Yes, sir.
యా సో ఇంకేమైనా డౌట్స్ ఉంటే అడగండి ఇట్లాంటివి.
So complex power values.
So next transformer. So here in the transformer, guys, just quick revision chestanu. In the transformer, are you? My voice is audible?
Yes, sir.
Yeah. So in a transformer, we have the two windings.
Sir,
Yes.
star delta connections problems చేద్దాం సార్.
Star delta connections. First you need. Okay. Give me any problem. Okay. Star delta. Okay. Mm. Some 24 volts. Then we have some 3 ohms, 6 ohms, 9 ohms, 7 ohms.
ఎప్పుడో జమానా కాలం మీద బంద్ చేసిన నేను.
Excuse me, sir. Sir,
Yes.
sir, I have a doubt in first chapter, sir, from Thevenin's theorem.
Hmm?
ఇదేంటో ఇప్పుడు ఫోన్ చేస్తే రాస్తున్నా.
Yes. Abhishek. Hmm?
Sir, previous year Thevenin's theorem को question రావట్లేదు sir.
Thevenin's theorem.
లాస్ట్ ఇయర్ 2020 క్వశ్చన్ ఒకటి ఇచ్చారు థెవెనిన్స్ థియరంది, అది రావట్లేదు, ఒకసారి కొంచెం సాల్వ్ చేస్తారా?
Send me that question. We will see.
ఓకే, ఐ సెండ్ ఇన్ MS Teams ఉంది.
Yeah. Okay. లేకపోతే నాకు వాట్సాప్ చేయి. Yeah. So here, so this is the star delta connection problem. So here, first calculate the equivalent resistance or equivalent. Suppose ఇక్కడ problem ఏంటంటే total current find out, calculate current or total calculate current supplied from the source. Calculate the current value which is supplied from the source. So it means it is I total. So if you want to calculate the total current, first we have to know that the total resistance, because of I is equal, we know that according to Ohm's law, I is equal to V by R. Right? So if you total voltage is there 24 volts, then total resistance. So in this resistor, so in this circuit, right, what is the possible combination? So here we don't have the any series parallel. Did you observe any series parallel connection here? We don't have any series parallel connection. You got my point?
Yes, sir.
So here we don't have the any series parallel connection. So then we prefer the star delta connection. So here so many means different stars are there, different what do you call, delta is there. So can you find out any star or delta? ట్రై చేయండి. ఏదైనా స్టార్ కనెక్షన్ ఉందా అసలు ఇందులో? డెల్టా కనెక్షన్ ఉందా?
Star connection is
విచ్ ఎలిమెంట్?
697.
697. That is one star. Only one star. That's enough.
395 also.
39. Yeah, 5. That is also star. Inka only two stars.
369 delta.
369. That is delta. Okay. Inka
795 delta.
yeah. So here the point is, here we have the so many deltas and so many stars. So here the point is, we are utilizing this star and delta conversion from star to delta and delta to star, this conversion for simplifying the circuit, not complicated again. So we have to analyze that which network we have to consider and we can convert. సో ఇందులో మనము అజ్యూమ్ చేయగలగాలి ఏ ఎలిమెంట్ తీసుకొని కన్వర్ట్ చేస్తే సర్క్యూట్ సింప్లిఫై అవుతుంది అన్నది, రైట్? ఓకే, సో హియర్ 697, if you are considering this this star, if you are considering 697 star and convert into delta, right, then the resultant value is like this. Just I am showing with a dot. Right. So now I am drawing according to that. I am drawing the circuit. Here it is 24 volts. So these are the previous as usual values. Here it is 3 ohms, here it is 5 ohms. So now I am removing the 697 with the new values. Those are delta values here. So here just I am showing those values. Those are some Rx, Ry and Rz. Right? So here I am converting from star to delta, right? So in star to delta conversion, see, these are Rx, Ry, Rz. These are the new values. These are the new values in delta. So how to calculate these values? How to calculate it? Rx is equal to, yes, what is the formula to convert from star to delta? Here I am converting from star to delta. Rx is equal to, right? Can you tell me that formula? Yes, Rx is equal to, while converting from star to delta, right? Here, I think here derivation. I didn't remember the formulas, but some numerator or denominator common ఉంటుంది ఇందులో. Star to delta, I think. Rx is equal to, ఆ డెరివేషన్ చేస్తే కానీ నాకు క్లారిటీ రాదు. It is between, here numerator common, I think, right guys?
Yes sir.
ఒకసారి చెక్ చేయండి. I think numerator common ఇక్కడ. అదొక్కటి చెప్పండి, న్యూమరేటర్ కామనా డినామినేటర్ కామనా?
Numerator common, sir.
Denominator common, sir.
ఫ్రమ్ స్టార్ టు డెల్టా.
Start to delta.
Denominator, sir.
Common, sir.
Denominator, sir.
Okay. Okay, then here it is 6 into Rx is equal to 6 into 9 multiply to each other kada.
Yes, sir.
Yes, sir.
6 into 9 plus 9 into 7. 1 second. Check confusion. Sorry.
So start to delta lo numerator common, sir.
Yeah, that's what I'm telling. Yes. So here in numerator, multiply to each other. In star to delta, in numerator, multiply to each other. One second, guys. Yes, got it. So in numerator, multiply to each other. That is 6 into 9, 9 into 7, and 7 into 6. Coming to the denominator, here we are calculating between, see, just put the points. Here it is A point, B point, C point. The resultant value of the delta is also between the A point, B point, and C point, right? So here Rx between AB point, we are calculating this Rx value between AB point. So in star connection between AB points, what are the elements are connected? 6 and 9. Am I right? Between the AB points in star connection, 6 and 9 resistor is there. So which is not related between the AB points? What is that element? 7.
7.
Right? So same like as same like as Ry. Ry is equal, numerator same, 6 into 9 plus 9 into 7 plus 7 into 6, right? Divided by, see, here Ry between the B and C. Ry between the B and C, right? Between B and C, what are the elements are there here? 9 ohm and 7 ohm. Which is not related element here? 6. Then coming to Rz here again numerator same, 6 into 9 plus 9 into 7 plus 7 into 6 divided by, right here, which is not related element, 9. So we will get the Rx, Ry, Rz, right? So after that, we have to observe here. So we got the Rx value, Ry value, Rz value. Next to possible connection. What is the next possible connection here? See the circuit here. 3 ohms and Rx. What is the combination of these two? Rx parallel with 3, some Ra, right? Then Ry parallel with R5, Ry parallel with 5 ohms, some Rb, right? Then the next level circuit here. So now the resultant of these two elements, that is Ra, right? The resultant of these two element, that is Rb, right? Then Rz as usual, right? Then here it is some voltage, Vs voltage, and here it is, what is that? Ra, Rb, then it is Rz. Can you tell me next possible combination here? What is the next possible combination?
RA RB series.
RA-RB series.
So
With
that is Ra plus Rb, that is equal to Rc, right? Then I'm drawing the next level circuit. So here it is. Vs, here it is Rc and Rz. Can you tell me next possible combination here? What is the
RC
next
parallel with R3.
Right. So that is Rc parallel with Rz. That is R equivalent. So next possible combination is here. This is R equivalent. Then I total is equal to Vs by R equivalent. You got my point? While converting from delta to star, what we have to do while converting from delta to star? So same thing. Yeah. Delta to star lo denominator same. That is denominator. ikkade ippudu values ikkada ee delta undanukondi. Where is it? Hold on. Yeah. So we know that Rx, Rz, Ry. We have to convert into delta to star. So while converting from delta to star, what we have to do? Here denominator is same. From delta to star, so these are the delta values, some Rx, Ry, Rz. The points are same, A point, B point, C point. So now I'm going to make the new values. Those are star. Right. So here, these are the new values: Ra, Rb, Rc. So here denominator, Just these are the here Rx, Ry, and Rz. These are the known values because of we are converting from delta to star. So delta is the known values, right? Delta is the known values, and here what do you call RA, RB, and RC? These are the unknown values. Unknown values. This is the star. So we are converting from delta to star. So here denominator, just add all together. That is Rx plus Ry plus Rz, right? Rx plus Ry plus Rz. So here R1, Ra, we are the unknown values. So here it is Ra is equal to, I am calculating Ra. Ra resistor is started. This is the neutral point. In delta, we don't have the neutral, but in star, we have the neutral point, common point. One end of all three elements connected at one point, that is neutral. So here Ra is started from A point. Ra is started from A point. So in delta, from A point, what are the elements are started, connected? Rx and Ry. So that is Rx into Ry. Rx into Ry divided by Rx plus Ry plus Rj. This is for Ra, right? Then Rb is equal to, here again denominator same, that is Rx plus Ry plus Rz. Then coming to the numerator, here Rb is started from B point. Then from B point, what are the elements are there in the delta? Rx and Rj. Rx into Rz. From Rc is equal to, that is Ry and Rz by Rx plus Ry plus Rz. Right. ఇంకేమైనా డౌట్స్ ఉన్నాయా? ఇంకా
సార్ ఐఎమ్ అక్షిత్ సార్, నేను అడిగిన చాట్ బాక్స్లో పెట్టాను సార్.
అక్షిత్,
సెకండ్ క్వశ్చన్ సార్.
find the Thevenin's equivalent with respect to the terminals AB for the circuit in the following figure. Okay. So we have to calculate here Thevenin's equivalent with respect to the terminals AB. So here Thevenin's equivalent resistance we have to calculate. Thevenin's equivalent resistance we have to calculate, that is RTH. Circuit value చూడండి. Okay. Source voltage 5 ohms 25. ఇదే కదా సర్క్యూట్ అక్షిత్
ఎస్ సార్
చెక్ ద వాల్యూస్
కరెక్ట్ సార్ కరెక్ట్ సార్
So here what we have to calculate Thevenin's equivalent, that is RTH. So while calculating RTH, what is the basic thing, basic steps మీకు చెప్పాను క్లియర్గా నోట్స్ కూడా రాపిచ్చాను రైట్. సో బిట్వీన్ ద ఏబి రైట్ ఇక్కడ ఒక ఈక్వలెంట్ రెసిస్టెన్స్ ఉందనుకోండి, మీన్స్ బిట్వీన్ ద ఏబి టెర్మినల్స్. ఇక్కడ ఏబి టెర్మినల్ సపరేట్గా బయటికి ఇచ్చాడు. Yeah, here some is there, some point is there. So here load resistor is not there, right? Then just assume some load resistor is connected here between the AB, between the terminals antam kada ikkada some load resistor. Remove the load resistor, already remove chesam. Then the equivalent resistance between the removed terminals. So we have to calculate the equivalent resistance, that is RTH is equal to, then while calculating RTH, what we have to do in the circuit, if we have the voltage source, then remove it, and what you have to do, short circuit. If it is current source, remove it and make it open circuit. Do you remember this point? While calculating RTH, if the circuit has the voltage source, remove it and make it short circuit. If it is current source, remove it and make it open circuit. Yes or no?
Yes sir.
Yes, sir.
So now what we have to do here, just remove this current source as well as this voltage source. Remove it. After removing, what we have to do, make it here short circuit or open circuit. Here it is
Open circuit.
open circuit. Then here what we have to do here, short circuit, right? So now for this circuit, calculate the equivalent resistance, right? Then from a point నుంచి అనుకోండి, ఇక్కడ నుంచి, then current ఇటు flow అవుతుంది అయితే ఏమన్నా, here it is G. Then whatever that here it is, whatever the current flowing here, this is 20 ohms. Then here equivalent resistance, while calculating the equivalent resistance, current will flows ఇక్కడ ఈ పాయింట్ దగ్గర చూడండి మీరు, ఈ పాయింట్ దగ్గర సర్క్యూట్ ఈక్వలెంట్, సి ఇక్కడ నుంచి 2 పాయింట్స్ ఉన్నాయి, ఇక్కడ నుంచి 2 పాయింట్స్ ఉన్నాయి సర్క్యూట్ ఈక్వలెంట్ రెసిస్టెన్స్. దెన్ ఇక్కడ చూడండి, ఇటు ఏమైనా ఫ్లో అవుతుందా కరెంటు? ఆర్ మీకు ఇంకా క్లారిఫైగా చెప్పాలంటే, ఇంకా ఇక్కడ లాజిక్ ఇక్కడ కూడా క్యాచ్ చేయొచ్చు మీరు, లేదు ఇంకా క్లారిఫైగా చేద్దామంటే, ఇక్కడ 5 ohms 25 ohms, what is the combination of these two, 5 ohms and 25 ohms?
Series.
Series.
5 ohms and sub parallel ఎలా అవుతుంది? Parallel ఎలా అవుతుంది నాన్న? See, ఇక్కడ some current వస్తుంది అనుకోండి, let us assume some Ix current. What is the current flowing through 5 ohms resistor? Ix. The same current will not flow here. Same current is coming here. Here also it is Ix. Then 5 and 25 is 5 plus 25, that is series, it is 30 ohms. Can I draw the next level circuit? చూడండి ఇక్కడ సర్క్యూట్ ఆషామాషి సర్క్యూట్ కాదు ఇది. Then here it is 20 ohms. Then from this point it is short circuited. Then here it is 25 ohms. Here it is 10 ohms. Here it is open. A point, B point. Here it is 20 ohms. Then here it is short circuited 10 ohms. Here it is 60 ohms. Now here current from A point to B point. Current is started from A point only. Then current is coming here I total. Then current is coming I total. Then here from this point actually current supposed to be divided. So here some Ix, here some Iy. Now can you tell me what is the Ix value?
I total into 20 by
Total
20 plus 25.
What is the Ix value?
Zero, sir.
Sir, 25 కాదు.
Zero, sir.
Hmm?
30 ohms.
సార్ 5 ohms రెసిస్టర్ సార్
Hmm?
30 ohms వస్తాయి కదా సార్ 25 రాసి
5 ohms రెసిస్టర్
Sorry. 30 కదా ఇది. Okay. Whatever. 30 or 100, whatever. What is the Ix value?
Zero, sir.
Guys,
Sir, Ix value is IT times the resistor present in different branch, but there is no resistor since it's zero, so Ix is zero.
Ix equal to I total, sir.
Ix is equal to I
No,
total.
sir. It is zero, sir.
Zero, sir.
Why it is 0?
Why will the current go in the path where a resistor is there when it has free path?
That's right. So here the simple thing here, please all of you just listen, just try to catch my point here. So here whatever the current coming here in this path, so here it is the node point is there, then the current supposed to be divided, but in this path we don't have any resistor. In this path we don't have the resistor value, right, is equal to 0. Then in this path some resistor is there to oppose the current. What is the resistor definition? It will oppose the current. So here మీకు ఇది ట్రాఫిక్ పోలీస్ ఎగ్జాంపుల్ కూడా చెప్పాను. If you are traveling with a bike and suppose if you don't have the any documents, then from the chaurasta, from that Nagol chaurasta, assume that one route, right, we don't have the traffic police, and another route we have the police. Then ultimately if you people will choose which path, in this path only. So the total current here Iy is equal to I total, right? Then Ix is equal to 0. Then we are not considering this 30 ohms. So here what is the R equivalent, R Thevenins here, that is 20. Then we are not considering this element, right? Then next total current is coming like this, 20 plus 10 plus 60. This is the RTH. How much it is?
90s.
Right? This is your equivalent resistance. Anybody have the doubt here? ఎటువంటి డౌట్ ఉన్నా ఇప్పుడే క్లారిఫై చేసుకున్నాను.
No,
ప్లీజ్.
sir, please explain that part again. 5 ohms and 25 ohms. 5 ohms and 25 ohms, that part. Once explain again, sir.
No, it is very clear. Suppose assume that, 1 second. So here it is short circuited. Here it is open circuited. Here it is 20 ohms, 5 ohms, 25 ohms, 10 ohms, and 60 ohms. So here we calculating the RTH. So starting from this point, right? Then current will not flow. I am calculating the equivalent resistance of the circuit. So current is started like this from this point. Here it is total current, then total current, right? Then coming the total current, and but here current is supposed to dividing. Some current is flowing through here and some current is flowing here. Equivalent resistance means if that resistor is counted or not. If the in that resistor if the current is flowing, then only it is counted. If the resistor is not working according to their characteristics, if the current is not flowing through that resistor, then we are that resistor is not counted in that circuit. You got my point? నేను ఇప్పుడు సర్క్యూట్ లో రెసిస్టర్ కనెక్ట్
Yes, sir,
చేశాను
but
అంటే
current is flowing through 5 ohms and 25 ohms. Nah, it will flow now.
5 ohms and 25 ohms.
We are considering 5 ohms and 25 ohms as series. So current will flow through that 5 ohms and 25 ohms.
How can it is current flow? Here some another path is there. In this path we don't have the resistor. ఈ పాయింట్ నుంచి ఈ పాయింట్ వరకు చూడండి ఇక్కడ ఈ పాత్ లో. Do you have any resistor here?
Okay, sir. I think okay. So according to what you say, it should be 30 ohms. RTH should be 30 ohms, not 60. Should not consider RL.
No, here RTH is between these 2 points. I am calculating the equivalent resistance between these 2 points. Then why it is 30 ohms?
RL, sir. We should remove RL.
Where is the RL?
60 ohms.
60 ohms is not the RL. Here between AB points, here if there some resistor is there between the AB points, here AB points not here, AB points here, some points is given. If some resistor is there, he is not given the resistor, right? Between
Okay,
AB
sir,
points.
Okay, sir, I got it.
Okay, na?
Yeah, sir. Okay.
Yeah. Okay, Nana, 2 minutes I will take the attendance.
సార్
Yes.
సార్ సోర్స్ ట్రాన్స్ఫర్మేషన్ మెథడ్ లో కూడా ఒక సమ్ చెప్పారా సార్?
Source transformation, huh? Okay.
ఎస్ సార్ టెక్స్ట్ బుక్ లో ఉంది.
M1, M2, M3, M4, M5, M6, M7, M8, M9, P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, Q0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 40, 41, 42, 43, 44, 45, 46, 47, 48, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 66, 67, 68, 69, 70, 72, 73, 76, 77, 78, 89, 80, 81, 82, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 96, 97, 98, 29, A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, B0, B1, B2, B3, B4, B5, B6, B7, B8. Yeah, guys, you can leave.
Sir,
Hmm.
so variable frequency is resonance frequency, sir.
Yeah, resonance. మీ డౌట్ ఏంటమ్మా?
Variable frequency is nothing but resonance frequency.
నో వేరియబుల్ ఎక్కడ వచ్చింది ఇది వేరియబుల్ ఫ్రీక్వెన్సీ?
In one question they said, sir, at variable frequency. So I thought it's resonance frequency. The question they mentioned that the given circuit is connected at a variable frequency, sir. Should I send you the question?
Which problem?
In the question paper, 1 minute.
Sir,